USB, page 215. My plan is up on the board. You were to watch a video lesson on 2.6, or 5.6 rather, special parallelograms. What a rhombus, special property of a rhombus. First of all, we know what is a rhombus from chapter 1 going all the way back. How do we, it is a special quadrilateral though. What's special about it? Yes, it has 4 sides, but, the 4 sides are, it's an equilateral quadrilateral. Equilateral quadrilateral. So, is it a parallelogram? Yes, it is. So we could even say, if we say it's an equilateral parallelogram, then we can assign all the qualities of a parallelogram to it. Okay, so that's kind of how we would fill that one in. It's equilateral, the sides are all parallel, opposite sides are parallel to each other. Is it equiangular?
No.
Could it be?
It's square.
That's the one example. A square is a rhombus. It's just an equiangular rhombus, right? Okay, rectangles are?
Quadrilateral.
They are equiangular. Another way to say it though, because of if they're equiangular and it's got 360 degrees, if we divide the 360 by 4, it's right angles, right? So all the angles are right angles, but that's the same thing as saying it's equiangular, all right? Squares are?
You're not wrong.
They are blank and blank parallelograms. What they are? Equiangular and equal side or equilateral, same thing, equal sides, which is what equilateral means. So they're both equilateral and they're equiangular and they are parallelograms, right? So we assign all of those properties to them. Look at the rhombus. That's rhombus A, B, C, D. I'm watching the chat bar too, guys. Are the diagonals perpendicular to each other? Are they? Yes. Huh? Do they bisect each other? Yes. Why? We know that because they are a parallelogram, right? Okay. Are they congruent to each other? No. Is there any situation where they might be congruent to each other?
Yeah.
A square. That's the only one, right? The one exception. Do they bisect the angles? Yes. For the same reason that a kite does, right? Okay? But the difference is, if I fold a rhombus on the diagonal, what kind of triangle do I get? Isosceles, which means that mid-segment going the angle bisector, right, the diagonal has to be the perpendicular bisector, it has to be all 4 of those things, right? Okay? So let's talk about a rectangle. We're on 215. Are they perpendicular? Are the diagonals perpendicular?
No.
Do you notice that they draw these figures a bit exaggerated so it's easier to see? If you were to make that, the closer you get to a square, the more it's harder to see the properties, right? Okay? Do they bisect each other? Yes. And here's the thing. This is like thinking about like a Venn diagram, like sets, right? All rectangles are parallelograms. And the diagonals of all parallelograms bisect each other. That's why we keep emphasizing that if it's a parallelogram, then everything we know about a parallelogram applies to that figure, right? Okay, so we do know that they bisect. Are they congruent? Yes, right? Normally a parallelogram they wouldn't be, but this one they are, and it has to do with it's the equiangular parallelogram that makes that true. Do the diagonals bisect the angles? No.
Does it go through the corner?
You can kind of see that as you stretch. The more you stretch out that rectangle, good job answering questions, Isaac. He's got it. Right. Yes. square. Down at the bottom, okay? We're not doing the proofs. We've done a lot of that, talking through that already. Are they perpendicular?
Yes.
Are they diagonals, right? We're talking about diagonals. Yes, they are, okay? And again, this has to do with isosceles triangles, right? When we fold the one on top of the other. Do they bisect each other? Yes. Are they congruent? Yes. Do they bisect the angles?
Yes.
In this case, yes. How do we know for sure?
Because it's also a wrong side.
That's true. You're right. And another way, though, for me, I think of if I fold it on a diagonal, I get an isosceles right triangle, which is going to be what we call a special triangle in next best risk. We have two special triangles, the isosceles right, which means we're left with how much for the other two angles. If the 90-degree angle is at the top, what's left for the other two angles? Half of the 90, right? If you think of an isosceles right triangle, okay? If this is the right angle, because I can't make those the right angles, right? This is kind of the easiest way. If it's a square, if it's the half of a square, what's left for these two angles? 45. So we would call this a 45, 45, 90 triangle, okay? There is a one. It's going to turn out, if you use the Pythagorean theorem, let's just say this side is a 1, this side would be a 1. The Pythagorean theorem would say that this is the square root of
2.
1 plus 1. 1 squared plus 1 squared would equal the square root of 2. So that ratio will always be true. If this is a 2 and a 2, this will be a 2 root 2. Whatever these are, we're going to use this a lot next semester.
Oh, is it like, if the 2 sides, like, right now it says 2, but like, is it n, it will be n root n?
Well, no, okay. Okay, I'm going to refer to this as a leg. Might as well. Right? If this is a leg, and this is a leg, right? Okay. Coming soon, right? This would be the square root of one leg squared plus the other leg squared. Well, that's the square root of twice the leg squared. Well, I can pull the leg squared out by the square root, and I get the leg times the square root of 2. That's why it will always be. Whatever that is, this will always be that times the square root of 2. Okay, we're going to the textbook, page 294. Always, sometimes, never. That's what these are. These are not true or false. So, if it's always true. If there's at least one exception, that would be a sometimes. Of course, if it's never true, it's never true. Take a look at number 1. The diagonals of a parallelogram are congruent.
Sometimes because of a rectangle, but not always because of a
Well, a rhombus or a well, it's not a parallelogram, but I mean any kind of parallelogram, right? As you stretch it, the diagonals become more and more. Is there a word? Uncongruent? Discongruent? Not congruent? Okay.
discontinuous.
So yes, sometimes there are some examples of that. Number 2, the consecutive angles of a rectangle are both congruent and supplementary. True. Always? Sometimes? Never?
Always, because it has to have 2 right angles.
They always have it. Yeah. I'm sure. They're all the same. So it doesn't matter where you're going. Any two you add up together, they will always add up to 90 plus 90 will be 180, right? Okay. How about number 3? The diagonals of a rectangle bisect each other.
Always.
Always. Because a rectangle is a parallelogram, right? And all parallelograms. All right. Number 4. The diagonals of a rectangle bisect the angles.
Sometimes.
Never.
If it's a square.
Never.
Never or sometimes?
Sometimes.
Oh, I'm getting lots of looks.
Sometimes. Think of a square.
She's right. A square is a rectangle, guys. A square is in the rectangle family. So if a square is a rectangle, we now have one exception. We have to say sometimes, right? Okay. Let's see. The diagonals of a square are the perpendicular bisectors of each other.
Always.
Sit front and center. I mean, there are other chairs. It's always, right? We actually, if you take a look, if you did this with SB page 215 open in front of you, you would actually see the answers to a lot of these questions, right? Okay?
Are we
You don't have, no, I'd like to see if you can remember, okay? How about is a rhombus a square?
Sometimes.
It could be true, right?
I
Okay.
think it's always, yeah, all the answers are
A
sometimes.
square is a rectangle.
Sometimes.
True. Always.
Never true.
We're always, sometimes, or never.
It doesn't
It's
feel
a
like
rectangle. It is a rectangle, always.
it just.
Okay, here's why some of you are confused. Is a rectangle a square?
Sometimes.
Sometimes, because the square could be the rectangle. Do you see why this is your logic class, by the way, guys? But is a square a rectangle? It's a special rectangle, so it will always be a rectangle, right? Okay, so the order of the words matter. Okay, all right. A diagonal divides a square into two isosceles right triangles. Okay.
Always.
If you draw, it is always. If you draw a square and you draw a diagonal, it's going to cut it right in half. The sides are all the same. The angles are all right angles. You will get two isosceles right triangles, right? Doesn't matter how you draw the diagonal, right? Okay. Opposite angles in a parallelogram are congruent. Opposite angles of a
Always.
parallelogram,
Always.
always. Okay. That's one of the, there's actually a conjecture about the opposite angles. We're relying on that. Now we've proven it to ourselves, okay? Consecutive angles in a parallelogram are congruent.
Sometimes.
Sometimes. Never.
Yeah.
Sometimes.
But it would be sometimes if, it would have to be a rectangle or a square, right? Because once you start angling it, you're going to have two non-congruent angles, right? Think of even a rhombus, right? Okay, 14. Okay, don't shout out answers. I want people to think about these. Is D-I-A-M, for diamond I'm assuming, is it a rhombus? Now, how do you know for sure? Because you can't exactly rely on your eyes. What do you think, Yoshi? How would you know whether or not it's a rhombus?
Don't trust my
Yeah.
Slopes.
Slopes. A rhombus is a parallelogram, so the slopes of the opposite sides would have to be the same, are they? Well, if you drew little triangles, right, I would, between D and M, I would go up 2, and I'd have to count over 1, 2, 3, 4, right? Up 2 over 4 would be a slope of 1/2. But if I go from M to A, it's not, right? Okay.
Yay.
So rather than relying on your eyes, right, when it comes to parallelograms on a coordinate plane, we would rely on slopes.
Because then if those are different, then it's definitely not. If they're the same, then it could be.
Yeah, it's another
So
way.
that's
You're actually doing one of the two slope. Yeah, you're doing one of the two slope ratios. Yeah.
So make it height.
Yeah. Well,
Good job,
it wouldn't
Cookie.
necessarily be, but in this case it is. To know whether it's a kite, you would have to actually use the Pythagorean theorem to test the distances. So the two sides. It turns out that is a kite. How would you know that boxy is a rectangle? Boxy is set. When you say you counted it, are you saying that because it's going to be based on slopes again. So I guess if you count the triangles and they're the same, what that's meaning is the slopes have to be the same. Because we're dealing with angles there. But if I'm looking at this from the perspective of slope, all I have to do, right? Yeah, you could do it visually though by sketching the triangles. If you sketch the triangles and they're the same by counting them out, then you know all the angles have to be. But the slopes have to be perpendicular to each other, meaning they have to be negative reciprocals of each other, right? Okay. So, and then how would you know if tile was a parallelogram? Number 16. How would you know that?
Oh, the slopes are all 18 over 10 or negative 10 over 18.
And another way, so you could have gone with slopes. To me, this might have been easier to notice. It's super easy to see that it's a rhombus. And obviously, the diagonals are perpendicular to each other, right? Is that what you were going to say? Yeah. Yeah. But it could be a kite. That's the only thing. Just because they're perpendicular doesn't mean it's a rhombus. It could also be a kite, but that's clearly not a kite, right? Okay. All right. Done with the textbook for today. Go to page 213, please. SB page 213. Let's talk about 4 through 11 is we're matching, but for these, the thing to be careful of is that there can be multiple letters. This isn't just one letter per number, okay? So take a look at number 4. Which of the figures up there would we say that the diagonals bisect each other?
Square.
Yeah, so that would be a G, right? Okay. What else?
A C.
C is another one. There are 2 more. Mm-hmm. There are 2 more.
Rectangle.
Mm-hmm.
Okay.
Not, wait, yes, kite. Let's see.
The diagonals don't bisect.
They don't, not, that would be perpendicular. Not, so there's still one left.
A.
Not A. Only if it was isosceles. That would be, it would have to be special, right? D. So let me ask you a question, guys. How many of, if you look at A, B, C, D, E, F, G, H, which ones are parallelograms?
G, F,
And C.
and C.
Right. So if C, D, F, and G are parallelograms, do you see why C, D, F, and G have diagonals that bisect each other, since all parallelograms have do you see what I'm saying? So if you know something's true for all parallelograms, then you know that's true for all 4 of those. Does that make sense? If they're in the parallelogram family. So they're not all going to be like that, but paying attention. So number 5, now which ones have the diagonals perpendicular to each other?
G.
E is 1, G is 1, there's 1 more, and D is the 3rd one, okay? So we've got, remember the rhombus and the the rhombus, the kite, and, square, obviously, yep, because the square is a rhombus, all right? F, the diagonals are congruent, not F, I said F, 6, I already said one of the answers. F is one of the 2 answers. So number 6, diagonals are congruent, and G, rectangle or square, because the square is a rectangle, right? Okay. Number 7, the measures of the interior angle sum to 360 degrees.
H.
H, all quadrilaterals, right?
So we have to write all the letters other than B, or
No,
just
H. H is an option. Just put H. That takes care of everything. Okay. The others are just specifically those things. Notice H would include, it could include something that looks like this. As long as the sides are straight. But, could be a completely irregular quadrilateral, but it still has 360 degrees, right? Because no matter how I draw it, if I draw a diagonal, I get 2 triangles. Right? Okay. Next, opposite sides are congruent. C. Yes.
F.
Yes.
G.
Yes. E. What'd you say? D. Yes. Aren't those the same letters of all the parallelograms? Because in parallelograms, the opposite sides are congruent to each other. How about 9? Opposite angles are congruent. Are we sensing a pattern here? C. G.
C.
D.
F, G, C.
And F. Because all parallelograms have opposite sides congruent to each other, okay? So notice anything that's true for all parallelograms, that would be 4, 8, and 9, that's going to be C, D, F, and G, because it's true about all parallelograms. And then 10, both diagonals bisect each other, that's not going to be true. Huh? D and G, okay? So what we're saying is, bisects the angles, right? It's not going to be true for all parallelograms, just the ones that have the square angles.
I didn't get number 6.
Number 6, F and G. Rectangle and square, if they have the equiangular parallelogram, that creates that congruence. Okay, once you start messing with the angles, the diagonals are going to change from each other. Okay, and then finally 11, diagonals are perpendicular bisectors of each other.
G.
G. One more.
D.
D. Okay. The rhombus, right, and the square. Those are the only two that will be true. Okay. All right. So that's basically going through your understanding. Let's go to 216. A few more of these where you have to try to. A few of you are like, these are hard. Okay, they're not that hard if you just kind of think them through. Number 1, the perimeter of triangle RAD.
That's rad.
Rad. Rad is 24 centimeters, and the perimeter of RAW is 21. Okay. They also have told you that AU is 7. Okay. I have a question for you. How can we find what did one triangle was 21 and the other one was 24? What's the difference? That's okay.
The difference is 3.
And what makes the difference? 3. But what made that difference?
Oh,
What's different between the two triangles?
RD versus AU. And so if you just subtract AU.
The diagonals are the difference, right? They both include 2 of the sides. So the only we know that diagonals are different by 3. That's what that tells us, right?
I'm so happy
It's raining?
Is it raining?
Yeah, it's raining here now. It's actually, Abe's telling me that his Wi-Fi is bad right now because there's a storm rolling through. I'm like, storm? Okay, all right.
Zeus is happy. Just kidding.
I just hope it stops raining as we get picked up.
Okay, at least it's not high traffic time. Okay, so guys, how do I use that? If they told me that if AU is 7, what does that tell me? Come on, huh? Logically, if AU is 7, then?
That UR plus AR.
Okay, we have a difference of 3, that's the diagonal. What we're saying is one diagonal has to be 3 longer than the other, so RD has to be 10, okay? We're just looking at what's different. One has the shorter diagonal, the other one has the longer diagonal. The longer diagonal is 3 units more, therefore it has to be 3 units more, right? Okay, so if that one's 7, the other one is 10. And what did they ask me for? They asked me for RD. If they asked me for RL, what would I have answered? 5. Because the diagonals bisect each other, right? Okay. Take a look at number 2. This is a little bit trickier, a little bit. The perimeter of dock is 18.
What's that?
The perimeter of car is 26. Okay. We're actually thinking if you kind of diagram in red a little bit, they also gave us a little bit more information. You might as well write it down. CO is 5, therefore CR is wait. So if CO is 5, then CR is
5.
CR?
No.
Oh,
10.
C or is 10.
And they told me that CA is 9, right? What I would do, I would start by figuring out what is AR. That's what I would start out with. What's AR?
7.
How do you know that?
Because we know cause.
So
And
we
so
know it's
10 plus
26. So if we subtract 10, we get to 16. And if we subtract 9, we get to 7. So that's left over. We now know that AR is 7, which tells us that CD is also 7. So we're kind of getting down to writing down what we know. Okay. How could I find the length of DO? I'm nearly there.
18 minus 7 minus 5.
Yeah.
Wait, where are we?
Number 2. 216. I'm going in order, as always.
I thought you were saying that's the perimeter.
Okay, if you've been writing these down, did you understand that? Okay, all right, okay. So if AR is 7, then we know that DC is 7, right? If CR is 10, then we know that CO is 5, right? So to get to DO, we take the perimeter around, which is 18, subtract how much? 12. We're going to get 18 minus 12, 16, okay? 16 centimeters, all right? So again, just using some logic. A lot of times with these puzzles, write down what you can figure out, right? They're not completely undoable. I'm going to look down at the challenge problem.
Yay.
So you don't get a whole lot of numbers here. I'm going to sketch this one out. There are no special angles, guys. It's scaling. Just assume, okay? No right angles, nothing special. But it has been trisected, not bisected, but trisected. So I've got triangle A, D, G. Right. So we have A, B, C, D, E, F, and G. Okay?
Too many letters.
They told me CE is the mid-segment, okay, of triangle BDF. So if that's the mid-segment of that, that is half of that, right? Okay? I'm just going to kind of, I don't know what this is, but I'm just going to use a little algebraic thinking. If that's X, what would BF be?
2x.
Twice X. So let's just kind of think about that. Maybe we can get somewhere with, I'm just kind of writing down, I don't know what that is, but whatever it is, this is twice that. Notice I don't put that as X and make that a half because then I would have to work with fractions. Right, so choose the way that you don't have to work with fractions. All right, let's look at the next one. BF is the mid-segment of ACEG. Okay? ACEG. Right? First of all, if it's the mid-segment, it's really the mid-segment now of a trapezoid, right? Okay? So if it's the mid-segment of a trapezoid, how could I get down to what this might be in terms of this?
2x minus x is just x. And so then you add x to 2x to make it 3x.
Yeah, I would just think, I'm thinking whatever this distance is, it's an x.
Yeah.
So this distance has to be an x, therefore this has to be 3 x's. Okay, right? Right? And notice, if I'm looking at the trapezoid, right, well, x plus 3x is 4x, half of that is 2x, right? It's consistent, okay? So I kind of know that much. Uh-huh. Well, let's look and see if did they give us any numbers here?
You. They gave us
A few. So triangle ACD is 17, right? The perimeter, okay? This little triangle. So the perimeter of this little triangle, maybe I'll call this A and B, okay? Why not? Okay, okay. So I could say, if I wanted to, that A plus B plus X is equal to what? What did they tell me?
Oh,
17. I have actually not found a way to do this without algebra. If anybody ever has, I always challenge people, if you can find another way to puzzle your way through this, when you come up with the answer, there's probably a way to do it if you have nice numbers. What else did they tell me? The perimeter of ACEG is 46, okay? So of the trapezoid, right? Okay.
The answer is
So
16.
if that's A, what does that have to be? If this is a mid-segment, what would that have to be equal to?
A.
Another A, right? And in fact, if this is a mid-segment of this trapezoid, what does that have to be?
A.
Another A.
And so
And of course, these are B's. So actually, we have equal proportions on the sides. Okay, I would not ask you to do this by yourself, but see if you can follow it. So what they're saying is twice A plus twice B, right? Plus what?
Plus 4x.
4x, because I'm adding these two, right? Plus 4x is equal to, what did they tell me? It's equal to 46.
Oh. Whoa.
So I mean, kind of technically, this is a systems of equations, right? But this is going to eliminate very easily if you do what?
Relation.
Yeah, but I would first, if I can
Divide.
simplify one of my equations a little bit down, what can I do?
Divide.
17
What did somebody say?
Divide by 2.
Divide by 2. And this becomes divide by 2. A plus B plus 2x is equal to 23. Okay, if A plus B plus x is equal to 17, oh come on, I don't even have to do any work here. What does x have to be logically?
6.
The difference. It has to be 6, right? Okay. So now we know that x is equal to 6 centimeters, and we can fill in anything from there that we like. What did they ask us to do? They asked us to find that, so we're done. That's all they asked us. If they asked me for the base, it would just be 18, right? Okay? I made it look easy, huh? But it's not too bad. We are virtually done with chapter 5, all right? Let's kind of review. What do you already know? This is a quadrilateral practice test. What did you learn? All right? Everybody think about these. These are the ways I help prepare you for your quizzes, okay? So every now and then I have something that I've said like 3 or 4 times in a class and people will miss that on a quiz. I'm like, where were you? What were you thinking, right? Okay? The measure of an interior angle on a regular octagon is. There are 2 ways to go about this. There are 2 ways to go. There's an easy way and there's a much more involved way. What's the easy way? Does anybody remember? We're going in order and it's on the board. Let me remind you. Okay, some of your biggest mistakes on the quiz were arithmetic, working with large numbers, especially if you did it by hand, decided not to use a calculator, and then made some silly little arithmetic mistakes, which I recommend doing mental math all the time. On a quiz, I would probably check answers with a calculator, but you have 2 ways of getting the interior angles of a regular figure. One is to remember how many triangles are in an octagon? 6. It's 8 minus 2. Whatever the number of sides are, minus 2 is the number of triangles. Okay? All right? So, in fact, that was the first question on the quiz. I had a lot of people missed that. Okay? But so you have the number of triangles are n minus 2. In this case, that means there are 6 triangles. There are 180 degrees per triangle. And then I'm going to divide that by the number of sides because it's an equilateral. So then I end up with, well, I could do a 4 and a 3. I could think 3/4. You divide by it would be 45 times 3, and I get to 135. I'm going to tell you, though, there's a much easier way to do this if you remember something else. What are the exterior angles of an octagon? What do the exterior angles add up to of an octagon? 360. The exterior angles of any polygon add up to?
360.
So notice, if I take 360, if I divide by 8, right, which would mean take half, you could do, or you could do those multiple. Well, 8 goes into 36, how many?
45.
Right, okay. If you come up with the 45, right, you can, so if each exterior angle, guys, is 45 degrees, what are the interior angles have to be? 135. And this is how, hey guys, what if you had I'm gonna make it a 27 gone, okay? Well, I could plug that in and do all that, but notice, what else could I do? Take 360 and divide by
27.
27, and what do you get? Yeah, I'm just doing this right now. What do you get?
13.3.
Okay, subtract that from 180, and you get, and by the way, of course, this is if it's regular, because if you, otherwise you don't know what all the angles are.
166.66.
166, say, 0.7 degrees, right? I mean, that's easier than plugging into here, right? Okay? So you get 25 times that divided by 27, right? So you'll get there, but it's kind of nice remembering the 360, right? Because it's true for everything. All right. If the exterior angles in a regular polygon measure 72 degrees, how many sides does the figure have?
With the exterior angle?
Of the exterior angles. If each one is 72 degrees, it has to be a pentagon.
Has to be an angle.
Because, why?
Because the sides add up.
If everything adds up to 360 and each one is 72, 360 divided by 72 is 5, right? Okay, all right. The sum of the interior angles in a polygon is equal to the sum of the exterior angles. How many sides does this polygon have? Somebody raise your hand. Someone who has it. Answer the question, because this is not hard if you think about it. Isaac Miller has already answered that question correctly. So has Selah. This is not hard.
5.
Not 5. If you're close.
She does it at 172.
It's
If
6.
the sum, listen, if the sum of the interior angles
8.
is the same as the sum of the exterior angles,
4.
4. Yes. Because if there's 360 on the outside, if there's 360 on the inside, it's a quadrilateral. Okay? In an isosceles trapezoid, 2 of the angles measure 56 degrees.
This one.
What are the measures of the other 2 angles? There's another really easy way to answer this question if you remember something. Huh? What do you have? Yeah.
What did she say?
124.
Yeah, I know.
Magically, 124 and 54 add up
68.
to 56 add up to
Wait, 68.
180 because
Wait.
the consecutive angles of the trapezoid are supplementary. They add up to 180. Okay, so if one's 56, the other's the supplement, right? Gets up to 180. All right? A lot of these are just not that hard if you can. Does everybody? This is probably the easiest way for me to remember this. All right? Okay.
Oh, a
So,
trapezoid.
a trapezoid. And
I was doing a triangle.
they did 2 of the measures, right? So if 2 of the measures are 56, that means it is isosceles, right? So if this is 56 and this is 56, that's what that means, right? How do I know it's not those? Because those are obtuse, right? Okay, I can assume that. But remember, if I were to chop this in half, do you see why these have to be supplementary? Because I've already got 180 degrees right here. So these have to be 180 degrees, right? So you just subtract from 180 to get there. All right? Kind of a visual proof of that. The two vertex angles in a kite measure 55 and 170. But what are the measures of the non-vertex angles? If you understand what a kite is, this is not that difficult. You may use a calculator.
67.5.
67.5. How did you get that?
I basically added up 170, 55, and minus.
Yeah. Okay, there's 360 in the whole total, right? If the two vertex angles, right, are 170, what is this going to look like, by the way? It's going to be this like super weird, you know, like that, right? If that's 170, and then what you have is something way down, you'd have to have it way down here to have, say, 55. You can kind of, when we talk about these vertex angles, these are the two. It's like a stew right now, right? But what's left has to be divided in half to go into these two because these are going to be congruent. These are the little wings, right? Okay? So, and then it's just math. Right?
You can't get it out.
Everybody understand that? Okay, because I get 135 left after I subtract, divide it in 2, I get 67 and a half. And okay, if you guys on quizzes and tests use a calculator to validate your math, okay? The perimeter of a triangle formed by the mid-segments of triangle ABC is 14 inches. Okay, so what are we saying? So we have a larger triangle, right? Some larger triangle. If we do the mid-segments, here, here, and here, what they're saying is the perimeter of this triangle is 14 inches, okay? If this is A, B, C, okay? They said that if AB is 6, not 5, so if this is 6 and this is 12, what's the perimeter of ABC if this one has a perimeter of 14?
Oh, the tiny one has a.
If this one has a perimeter of 14, right? This has to be 28, guys,
10.
right? Remember, this is 1/2 of this, and this is 1/2 of this, and this is 1/2 of that. You guys understand, right? So if that little triangle in the middle, it's got half of the lengths and 1/4 of the areas, because area is a squared dimension, right? So if I have half the length and half the height, I'm going to have 1/4 of the area. All right? That's how we get 4 of them there. Trapezoid. EFGH has bases measuring x minus 10 and 3x. If the midsegment is 19 inches long, what is the length of the short base? Let me sketch this out. It's easier to understand if you have a sketch, right? So I have a trapezoid here, and it told me the mid-segment, what did they say? One base is 3x, and the other is x minus 10. I don't know which one's bigger, right? Well, no, I do know which one's bigger. That one's going to be smaller than that one. Okay, but what else did they tell me? They said that the mid-segment here is 19, and did they give me inches there? How could I figure out the length of the short base, which is really that, right? Who's got an answer? Sam's got an answer. Alex?
It's 4x minus 10 equals 19. So 4,
If you add the two together,
it's
you get
19
4x
it's 19 over 4.
minus 10, huh?
19
If I
over
add, this is going to be the average of the two bases.
Oh.
So if I average this, what does that mean?
So
Means divide by 2.
2x minus
So
10 is
I'm going to get
13.
2x minus 5 is equal to 19. Okay? Because in other words, add the two bases together and divide by 2. That is averaging the bases. So I'm going to get this is equal to this. Don't forget to divide them both by 2. 2 times x is equal to 24. X has to equal 12. What was the question?
What's the short side?
Yeah, so don't put 12. What is the short side?
2.
2.
Whoa.
It's 2. You see what? If x is 12, 12 minus 10 is 2. What's the big base? 3 times 2. This is 3 times x, so this would equal 36. If we did our math right, 38 divided by 2 is 19. Should always go back and check it. Should make sense, right? Okay. Before I put the game on the board, I'm gonna put up a couple of card questions that I want you guys to. I want to see that everybody is remembering. This is my question. If you have an m of 1/2 and the line has negative 6,3 on it, give me the equation. There's a B term for this. Yep.
Is this it?
It's positive because you have a 3 on the other side that's positive. Yep. Yep. Okay. Yep. I just want to make sure everybody can do it's not minus this plus. To add 6 to get a positive 3 on the other side. So y is equal to 1/2 of x plus 6. Okay. So everybody, y is equal to 1/2 of x plus 6, right? Okay. What would the slope of a parallel line to this be? The slope of a parallel line. Put it on your boards. Parallel. Yeah, the slope is just going to be 1/2. Okay? It would be. We don't put an x on there, guys. Slope is always a number. It is just a 1/2. It's the m in front of the x. Is slope. All right? Okay. In other words, if the point at 5,2 is on this line, and that's the slope, give me the equation. And yes, this will involve fractions. Be careful.
Oh god.
It's not that bad. You just have to turn your 2 into thirds. If you turn your 2 into 6/3, this is not that bad. Got the right B term? It does say find B, but I'm also asking you to state the equation. Not 1/3. Eh? Yes, that one's correct. I've only got 2 correct answers with the B term. Yes, that is correct. Oh, you're so close. You make. I'm sure that's an arithmetic error. You seem shocked you got it right. No, you're still off. Okay, hey guys, you're solving for, right? Okay, so if you could imagine the 2 is on the other side. I could look at that as 6/3, right? 6/3 is equal to
40.
Huh? What is 5 times negative 8? Yeah. So 6/3 is equal to, but it's negative, right?
Oh, okay. So I was just wrong.
Yeah, you did that. Okay. I'm solving this equation. Do you see why B is, what is B? 46/3. Put the equation together, it's not that bad. Where are you making mistakes? Probably. But always turn, if you're gonna be left, if you do this multiplication and it doesn't simplify to an integer, then turn this into a common denominator fraction, because otherwise you're gonna make mistakes, right? Okay? Does everybody see why if I add both sides, B is 46/3, and so on. So y is equal to negative slope to this line be?
Do it.
This is not a hard question. And it's a number, and somebody's already, you didn't have to come up with the equation, I just asked for the slope this time, but it is easy. That was it's the negative reciprocal. You have to flip it and change the sign. Okay? All right? Okay? Just, let's finish this over again. Okay? All right.